Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Chapter 7, Lists in Python, Part 2, for the Class 11 students of Computer Science. In this video, we are going to discuss about operations on lists, concatenation, replication or repetition, membership testing, indexing, slicing, nested lists, copying lists and practical implementation. So let's dive in and get started. In Python, there are several built-in list operations available for manipulating and working with lists. Here are some commonly used list operations: concatenation, replication, membership testing, indexing and slicing. Let's see one by one in detail. Let's learn about the concatenation of lists. Concatenation or joining is a process in which multiple sequences or lists can be combined together with the help of certain operators. Python allows combining or adding of two lists using plus concatenation operator, addition operator. We can add two lists using this operator. Let's see some examples. Example 1. Adding two strings using the plus operator. In this example, we have a list L1 initially containing two strings, computing and technology. Using the plus operator, we concatenate the list L1 with another list containing a single string research. The plus operator concatenates the two lists together, resulting in a new list L1 with three elements: computing, technology, and research. The updated list is then printed, resulting in computing, technology, research. Now look at the second example. Adding two lists. In this example, we have two separate lists: become, computer, and scientist. Using the plus operator, we concatenate the two lists together. The plus operator combines the elements of both lists, resulting in a new list L1 with three elements: become, computer, and scientist. The concatenated list is then printed, resulting in become, computer, scientist. Example 3. In this example, we have two numeric lists, L1 with elements 10, 20, 30, 40, and L2 with elements 50, 60, 70, 80. Using the plus operator, we concatenate the two lists together. The plus operator combines the elements of both lists, resulting in a new list L3 with 8 elements: 10, 20, 30, 40, 50, 60, 70, 80. The concatenated list is then printed, resulting in 10, 20, 30, 40, 50, 60, 70, 80. In all three examples, the plus operator is used to concatenate lists or strings, resulting in a new combined list or string. The plus operator, when used with lists, requires both the operands to be of list types, otherwise it will result in type error. Let's see some examples. Example 1. Look at the Python code. The code attempts to concatenate the list L1 with the integer value 20. However, this operation is not supported because you cannot directly concatenate a list with an integer in Python. It would result in a type error. Example 2. Here, the code attempts to concatenate the list L1 with the string Python. However, this operation is not supported because you cannot directly concatenate a list with a string in Python. It would result in a type error. Thus, we conclude that the plus operator, when used with lists, requires both the operands to be of list types. In Python, you can replicate a list by using the multiplication operator, asterisk. The asterisk operator allows you to repeat the elements of a list a certain number of times. Let's see some examples. Example 1. In this code, the list L1 is multiplied by 2 using the asterisk operator. This replicates the elements of L1 2 times, resulting in a new list, 5, 10, 15, 5, 10, 15. You can check the output on the console. Example 2. In this code, the string hello is multiplied by 3 using the asterisk operator. This replicates the string 3 times, resulting in the output hello hello hello. You can check the output on the console. Example 3. This code attempts to multiply the lists L1 and L2 together, but this operation is not valid. It will raise a type error because you can only multiply a sequence, for example, list, string, with an integer. You can check the output on the console. Let's learn about membership testing. Membership testing in lists involves checking whether an element is present in a list or not. Python provides the in and not in operators to perform membership testing. Python offers 2 membership operators to check or validate the membership of a value. It tests for membership in a sequence, such as strings, lists, or tuples. Let's see about the in operator. The in operator is used to check if a character or substring or element exists in a sequence or not. It evaluates to true if it finds the specified element in a sequence, otherwise false. Let's see some examples. Example 1. In this example, we are checking whether the character uppercase S is present in the string summer vacation. Since the character uppercase S is indeed in the string, the result is true. Example 2. In this example, we are checking whether the character lowercase s is present in the string summer vacation. However, Python is case sensitive, so it considers lowercase s and uppercase s as different characters. Since the lowercase s is not present in the string, the result is false. Example 3. In this example, we are checking whether the string vacation is present in the list summer, vacation. Since the string vacation is indeed in the list, the result is true. Example 4. In this example, we are checking whether the number 50 is present in the list 50,000, 5,000, 550. Since the number 50 is indeed in the list, the result is true. In all of these examples, membership testing is performed using the in operator, which returns true if the element is present in the sequence and false otherwise. Next, we can see about not in operator. The not in operator returns true if the element does not appear in the list, otherwise returns false. Let's see some examples. Example 1, S equals pen, notepad, paint, brushes. This line of code creates a list S that contains the elements pen, notepad, paint, and brushes. Second line, print of pencil not in S. This line checks if the string pencil is present in the list S. Since pencil is not in the list S, the expression pencil not in S evaluates to true. Therefore, the output of this line would be true. Second example, X equals 10, 20, 30, 40. This line creates a list X that contains the elements 10, 20, 30, and 40. The next line, print of 10 not in X. This line checks if the value 10 is present in the list X. Since 10 is present in the list X, the expression 10 not in X evaluates to false. Therefore, the output of this line would be false. You can check the output on the console. In this method, the membership operator in can be used to display the elements of a list through for loop. Let's see an example. Write a Python program to display the names of students who are members of class 11. Now, look at the Python code. The line, students_11 equals Sam, Mary, Mac, Kevin, defines a tuple named students_11 that contains the elements Sam, Mary, Mac, and Kevin. Next line. For namelist in students_11, starts a for loop that iterates over each element in the tuple students_11. On each iteration, the current element is assigned to the variable namelist. The print of namelist prints the value of namelist during each iteration of the loop. In this case, it will print each name in the tuple students_11 on separate lines. You can check the output on the console. Let's discuss about indexing. In order to access the list items, refer to the index number. We use the index operator, square brackets, to access an item in a list. The index must be an integer. Nested lists are accessed using nested indexing. Let's see an example. Shopping_list equals apple, orange, bread, butter, pen, notepad. Now look at the picture. In Python, indexing starts from 0. In the shopping list, we have 6 items in this particular sequence, and the positive index range is from 0 to 5, from left to right. An index is a number specifying the position of an element in a list. It enables access to individual element in the list. Index of first element in the list is 0, second element in the list is 1, and nth element is n-1. Negative indexes identify positions relative to the end of the list. The index -1 identifies the last element, -2 identifies next to the last element, and so on. Now look at the Python code. Print of shopping_list of 0 will display the output as apple. Print of shopping_list of 3 will display the output as butter. Print of shopping_list of -3 will display the output as butter. Print of shopping_list of -5 will display the output as orange. Slicing is a feature in Python that allows you to extract a portion of a list. It provides a way to create a new list by specifying a range of indices. The general syntax for slicing a list is list of open brackets start : stop : step close brackets, where start is the index where the slice starts, inclusive. If not specified, it defaults to the beginning of the list. Stop is the index where the slice ends, exclusive. If not specified, it defaults to the end of the list. Step is the increment between indices. If not specified, it defaults to 1. Let's see some examples. Let us consider a list or sequence as x equals SOFTWARE. The various slicing operations performed on this sequence is shown on this table. Now look at the table. Example 1. X of 1:4. Now look at the above picture. X of 1:4. Here start value is 1 and stop value is 4 exclusive. So stop value is 3. Step value is not given, so we take the default value 1. Hence, x of 1:4 slices the items 1 to 3. So the output is OFT. Now look at example 2. X of 1:6:2. Now look at the above picture. X of 1:6:2. Here start value is 1, stop value is 6, exclusive, so stop value is 5, step value is 2 given. So items 1, 3 and 5 are sliced. So the output is OTA. Now look at example 3. X of 3:. Now look at the picture. Here start value is 3. Stop value is not given. Hence we take the default value until the end of the string. Step value is also not given, so step value is default value 1. So the items 3 to end is sliced. Hence the output is TWARE. Now, look at example 4. X of 5. Here start value is not given. So default value starts from 0. Stop value is 5 exclusive. So stop value is 4. Step value is not given. So step value is default value 1. So the items 0 to 4 are sliced. Hence the output is SOFTW. Now, look at example 5. X of -1. Now look at the picture. Here the start value is -1. Backward negative indexing, hence it slices the last item. The output is E. Now, look at example 6. X of -3:. Now look at the picture. Here, start value is -3, stop value is not given. so default value is the end of the string. Step value is not given, so default value is 1. So, it slices the last 3 items. Hence the output is A-R-E. Now, look at example 7. X of colon minus 2. Expression represents a slice of the list X from the beginning to the second to last element. Start value is not given, so default value is 0. Stop value is minus 2 exclusive and hence stop value is minus 3. It excludes the last 2 elements, R and E. So all except last 2 items are sliced. Hence the output is SOFTWA. Let's see some more examples, how slicing operations are performed. Let us consider a list L1, with the values 20, 10.75, Python, coding, 282.50. Now, the positive indexing and negative indexing are marked for reference. Now, look at the Python code. The first line initializes the list L1 with the values 20, 10.75, Python, coding, 282.50. Example 1. It then prints the list L1 as it is. You can check the output 1 on the console. Now look at example 2. Print of L1 of 3 colon. This line slices the list L1 from index 3 to the end of the list. It includes the elements coding, 282.50. The output would be coding, 282.50. You can check the output 2 on the console. Now look at example 3. Print of L1 of colon 3. This line slices the list L1 from the beginning to index 3, exclusive. It includes the elements 20, 10.75, Python. The output would be 20, 10.75, Python. You can check the output 3 on the console. Now look at example 4. Print of L1 colon 2. This line slices the list L1 from the beginning to the end in steps of 2. It includes every second element in the list. It displays from beginning till end in step of 2. The output would be 20, Python, 200. You can check the output 4 on the console. Now look at example 5. Print of L1 of colon minus 2. This line slices the list L1 from the end to the beginning in steps of minus 2. It includes every second element in the list in reverse order. It displays from end till beginning, reverse order, in step of 2. The output would be 82.50, coding, 10.75. You can check the output 5 on the console. Now look at example 6. Print of L1 of minus 5 colon minus 2. This line slices the list L1 from the minus 5th index to the minus 2nd index, exclusive. It displays from minus 5 index to minus 2 in reverse order. It includes the elements 10.75, Python, coding. The output would be 10.75, Python, coding. You can check the output 6 on the console. Now look at example 7. Print of L1 of 5 colon 2 colon minus 1. This line slices the list L1 from the 5th index to the 2nd index, exclusive, in reverse order with a step value of minus 1. It displays from 5th to 2nd position in reverse order with step as minus 1. It includes the elements 82.50, 200, coding. The output would be 82.50, 200, coding. You can check the output 7 on the console. Now look at example 8. Print of L1 minus 2 colon minus 5 colon minus 1. This line slices the list L1 from the minus 2nd index to the minus 5th index, exclusive, in reverse order with a step value of minus 1. It displays from minus 2 to minus 5 index position with step value as minus 1. It includes the elements 200, coding, and Python. The output would be 200 coding Python. You can check the output 8 on the console. Now look at example 9. Print of L1 of -2 colon, -5 colon, -2. This line slices the list L1 from the -2nd index to the -5th index, exclusive, in reverse order with a step value of -2. It includes every second element in the specified range. It displays from -2 to -5 index position with step value as -2. The output would be 200 Python. You can check the output 9 on the console. The slicing operation is entirely based on indexing. In case the resulting index lies outside the lists, Python raises an index error. List index out of range. Slice range, start and stop argument is treated as boundary and the result will simply contain all the elements which lie between the boundary. In case the start and stop limits lie outside the boundary, Python still returns the elements that lie between the specified range or boundary without raising any error. Let's see some examples. Example 1. In this line, we are attempting to slice the list L1 from index 2 to index 6. However, the list L1 has a length of 5, which means the valid indices range from 0 to 4. Index 6 is out of bounds and exceeds the length of the list. As a result, we will encounter an index error when trying to access index 6, but Python still returns the elements for the start value that lie between the specified range or boundary without raising any error. So the output will be list containing 33, 44, 55. You can check the output on the console. Example 2. In this line, we are trying to slice the list L1 from index 6 to index 10. Since the list L1 only has a length of 5, both the start and stop limits provided are out of bounds. The starting index of 6 exceeds the maximum valid index of 4, and the stop index of 10 is also beyond the list's length. Both the limits are out of bounds, still Python does not give any error but returns an empty list as no element of list 1 possesses the index that falls in the range of 6 to 10. So the output is empty list. You can check the output on the console. Let's learn about nested lists. Nested lists in Python are lists that contain other lists as elements. Each element within a nested list can be of any data type, including other lists. Let's see some examples. Example 1. List L1 holds the values 10, 20, C, M, a nested list holding the values 6, 7, 8, and 30, 40. The next line print of L1 of 4 retrieves the element at index 4 of the list L1. Now, look at the above picture. I have marked the positive indexing of the list in green color. It starts from index 0. Index 0 holds the value 10, index 1 holds the value 20, index 2 holds the string C, index 3 holds the string M, index 4 holds the nested list containing the element 6, 7, 8, index 5 holds the value 30 and index 6 holds the value 40. The element at index 4 is 6, 7, 8, which is a nested list. So the output displayed is a nested list 6, 7, 8. Example 2. Print of L1 of index 4 of index 1. Accesses the element at index 1 within the nested list at index 4. Look at the above picture. I have marked the nested list indexing with pink color. It starts from index 0. So index 0 holds the value 6, index 1 holds the value 7 and index 2 holds the value 8. The nested list 6, 7, 8 is at index 4, and the element at index 1 within that nested list is 7. Therefore, the output would be 7. Let's see some more examples. In this Python code list L1 holds the values of different data types. L1 equals values 10, 20, 30, string G, nested list holding strings, machine comma language, values 40, 50, 60 another nested list holding strings, artificial, intelligence. Now look at example 1. Print of L1 of 4 of 1. To understand this, at first look at the above picture for indexing the list. First, look at the green markings. Indexing starts from 0. So index 0 holds the value 10, index 1 holds the value 20, index 2 holds the value 30, index 3 holds the string G, index 4 holds the nested list, machine, language, index 5 holds the value 40, index 6 holds the value 50, index 7 holds the value 60, index 8 holds another nested list holding strings artificial and intelligence. Now we will look at nested indexing 1 in the picture, which is marked as pink color. Index starts at 0. Index 0 holds the string machine and index 1 holds the string language. Same way for the next nested list, index 0 holds the string artificial and index 1 holds the value intelligence. Now look at the nested list indexing 2, which is marked in blue color. I have written only for laprint of L1 of 4 of 1. And wage. So index starts from 0. Index 0 holds the character L, index 1 holds the character A, and so on. Now, let's come to the Python code. Example 1. Print of L1 of 4 of 1. This statement accesses the element at index 4 of L1, which is machine, language. Then, it further accesses the element at index 1 of that sublist, which is language. Therefore, it will print language. Now look at example 2. Print of L1 of 4 of 1 of 3. Similar to the previous statement, this statement accesses the element at index 4 of L1, which is machine, language. It then accesses the element at index 1 of that sublist, which is language. Finally, it tries to access the character at index 3 of the string language. So the output is G. Now look at example 3. Print of L1 of 4:7. This statement uses slicing to retrieve a sublist from index 4 to index 6 exclusive of L1. The resulting sublist is machine, language, 40, 50. Therefore, it will print machine, language, 40, 50. Now look at example 4. L1 of 4 equals Python. This statement replaces the element at index 4 of L1 with the value Python. The previous value, machine, language, is overwritten, and the new list becomes 10, 20, 30, G, Python, 40, 50, 60, artificial, intelligence. Now look at example 5. Print of L1 of -1. This statement accesses the last element of L1, which is artificial, intelligence. Therefore, it will print artificial, intelligence. Now look at example 6. L1 of 8 of 0 equals natural. This statement modifies the first element of the sublist at index 8 of L1. The previous value artificial is replaced with natural. The updated list becomes 10, 20, 30, G, Python, 40, 50, 60, natural, intelligence. Now look at example 7. Print of len of L1. This statement calculates the length of L1, which is the total number of elements in the list. In this case, it will print 9. Now look at example 8. Print of type of L1. This statement returns the type of L1, which is a list. It will print class list. Let's learn about copying a list. Given a list, the simplest way to make a copy of the list is to assign it to another list. Let's see some examples. Example 1. List 1 holds the elements 10, 20, 30. In the next line, the variable L2 is assigned to L1. However, it's important to note that this assignment does not create a new copy of the list. Instead, both L1 and L2 refer to the same underlying list object. Therefore, modifying the list through one variable will affect both variables. So print of L1 will display the list 10, 20, 30. And print of list L2 will display the list 10, 20, 30 respectively. At this point, both L1 and L2 contain the same elements, 10, 20, and 30. You can check the output on the console. Example 2. Here, we are appending or adding the value 40 to list L1. After appending the value 40 to L1, both L1 and L2 reflect the change since they refer to the same list object. At this point, both L1 and L2 contain the same elements, 10, 20, and 30, 40. You can check the output on the console. We can also create a copy or clone of the list as a distinct object by 3 methods. The first method uses slicing. Method 1. We can slice our original list and store it into a new list variable. The syntax is new list equals old list open brackets colon close brackets. Here is an example. In this case, L2 is assigned a copy of L1 using the slice operator open square brackets colon close square brackets. This creates a new list object with the same elements as L1. Therefore, L2 is an independent copy of L1. Printing L2 will output the elements 20, 40, 60, 80. Modifying L1 will not affect L2 and vice versa. Method 2, we can use the list constructor function list function. The syntax is new list equals list of old list. Let's see an example. In this code, L2 is assigned a new list object created by passing L1 as an argument to the list function. This creates a new list with the same elements as L1. Therefore, L2 is an independent copy of L1. Printing L2 will output the elements 5, 10, 15, 20. Modifying L1 will not affect L2 and vice versa. Method 3, we can use the copy function. The syntax is new list equals list of old list dot copy function. Let's see some examples. Example 1. In this code, L1 is initially assigned the list 10, 20, and 30, 40. L2 is created as a copy of L1 using the copy method. So L2 also contains the same elements, 10, 20, 30, 40. You can check the output displayed as 10, 20, 30, 40. Example 2. L1 of 0 equals 100. Modifying L1 by changing the value at index 0 to 100, using L1 of 0 is equal to 100, results in list 100, 20, 30, 40. You can check the output displayed as list 100, 20, 30, 40. Next line is print of L2. Since L2 is a separate copy, it remains unchanged and still contains the original elements of list 10, 20, 30, 40. Hence the output displays on the console as list 10, 20, 30, 40. Example 3. L2 of 2 equals 300. Modifying L2 by changing the value at index 2 to 300, using L2 of 2 is equal to 300, results in list 10, 20, 300, 40. You can check the output displayed as list 10, 20, 340. Next line, in print of L1, again, L1 remains unchanged and still contains list 100, 20, 30, 40. So the output displays list 100, 20, 30, 40. The copy functions returns a new list stored in a different memory location. It doesn't modify the original list, or the modifications made in the new list will not be reflected to the base list. Thanks for watching. Watch the upcoming videos. Chapter 7, Lists in Python, Part 3. Built-in functions, manipulating lists, deletion operation, sorting and practical implementation. You can check the link in the description box below.